Project 2, the Capacitor Visualizer. To construct a prototype of the Capacitor Visualizer, you will need a breadboard, some wires, 3 470 ohm quarter watt resistors, 2 push switches, a 5mm red/green bicolor LED, a 5mm yellow LED, and finally a 1000 microfarad capacitor, all powered by a 9-volt power source. Okay, now your capacitor visualizer is assembled, but how does it work? When S1 is activated, the circuit comes alive. Current may now flow through R1 and enter the anode of the capacitor, charging it. Through induction, current will pass through the capacitor and enter the anode of the bicolor LED, illuminating it red and then going to ground. The brightness of the bicolor LED is determined on how charged the capacitor is. If the capacitor is less charged, the more bright the LED will appear. Also, current can travel through R2, illuminating the yellow LED and going right to ground. Then, when S1 is deactivated, the capacitor now powers the circuit. Current comes from its anode lead, goes through R1 and R2, illuminates the yellow LED, and goes to the cathode of the bicolor LED, making it turn green, and then finally to the capacitor's ground, while simultaneously draining the capacitor. Finally, activating S2 when the capacitor is charged and S1 is deactivated, the current will flow through R3, the path of least resistance, right to the capacitor's ground, turning off the bicolor LED and the yellow LED, draining the capacitor extremely quickly. Then, after obtaining a custom PCB, you can now solder all of these components to the correct spots on the board and screw it all into a custom printed case graciously designed by Joshua Dolgan. And then you have a final product that works just the same as the breadboard designed capacitor visualizer. S1 charging the capacitor, temporarily illuminating the bicolor LED red through induction and illuminating the yellow LED, then releasing S1 discharging the capacitor, illuminating the bicolor LED green and the yellow LED, and finally S2 is acting as a quick drain method for the capacitor, doing the same as before, creating a new path for the current to travel through with the least amount of resistance, straight to the cathode of the capacitor, draining it and turning off the LEDs. That concludes Project 2 of my design engineering report, the Capacitor Visualizer.